Hey, so you have chosen and implemented Harness as your CD or continuous deployment engine. That's great. But as you now scale the number of developers deploying a growing number of applications across an even growing number of clusters and namespaces, you start facing issues around developer experience, enforcing policies and governance, and application management post deployment. And last but not least, the control of state using methodologies such as GitOps, which is not natively supported by Harness. So let's see how you can solve these issues. Alright, so before we go into the demo itself, let's see what a typical scenario looks like. You have your Harness account, right? You created an account at Harness for CD, and once you go in, you start configuring your different Kubernetes clusters. So you add your first Kubernetes cluster, let's say GKE. You can have your second cluster on EKS and your third cluster on EKS as well. It doesn't really matter. And you connect Harness to these clusters using the cloud providers or the provider configuration in Harness. And the thing is that now, once it's connected, for every app that you're deploying, you have to go through that kind of set of YAML configurations or Helm configurations for Harness to be able to deploy these applications into each Kubernetes cluster. And that's just a regular scenario, right? Because Harness works at a Kubernetes level. So your developers, they have to learn, create, and configure these objects. If you use a default approach, you start running into some issues as you scale, right? The first one that we can mention is the developer experience. Because Harness operates at the Kubernetes level, for your developers to be able to deploy their applications, they have to learn, create, and maintain all the YAML files, manifests, or Helm charts, for example. So you get your developers into the infrastructure layer level, where they have to learn what an ingress is, ingress rules, deployment sets, and so on and so forth. At the scale of hundreds or thousands of services and hundreds or thousands of developers even, this can become cumbersome and a burden to your developers, which decreases the developer experience, right? They spend time creating and managing infrastructure-related objects rather than spending that time on delivering the application, which is the core of the business. The second one is the post deployment management of the applications. It's not part of your CD pipeline, and usually we see a lot of organizations try to build that internally themselves with a bunch of custom scripts, which over time creates a lot of complexity as well. So how do you give your developers a post-deployment platform for them to manage their applications, connect into incident management, understand the object relationship of their application, as well as network map, and so on and so forth. As you grow the number of clusters and applications and users, enforcing policies and governance also is not easy, because this is not native to Harness. You have to build these policies on each and every cluster that you create, and usually you're going to have to go through kind of complicated legal rules and so on, and it's not ideal, right? Every time you scale on a new cluster or new apps and new teams, you have to kind of write those complicated rules. And last but not least, the control of state. You want to make sure that if a developer goes directly on Kubernetes, for example, and deletes a service or something happens, all these services and applications are automatically recreated and brought back to the state where it's defined in your Git repo. And GitOps is not something that is native to Harness as well. So let's see how we can start addressing that. So if we go back to the scenario where we have our Harness account and configure for our CD part, instead of delivering that to the different Kubernetes clusters, now instead we are going to be connecting Harness to our Shipa Cloud API. So we assume you already have a Shipa Cloud account. If not, again, shame on you. And that Shipa API then is going to be responsible for connecting to the different Shipa frameworks that I have, such as Framework 1, Framework 2, 3, and 4 here, for example. And the communication to the framework is going to be invisible to Harness itself. Harness is just going to see the Shipa API, and the Shipa API is going to be connected to the different frameworks. And as you probably have seen before, the different frameworks, they can be connected to different clusters, such as Framework 1 here, for example, can be connected to a Kubernetes cluster on Framework 2 can be connected to Kubernetes cluster on EKS. And frameworks 3 and 4, for example, can be connected to another Kubernetes cluster. And I can use these frameworks, such as framework 1 for production, framework 2 for QA, and frameworks 3 and 4 for development, for example. And each of them, they have different rules. And Harness is just pointing to the Shipa API, right? So there is only one single configuration. As you scale the number of clusters, you don't need to go to Harness and create and configure each different cluster. Harness is just going to send Shipa API the app info, saying which framework to use, which team is the owner of the application, and the definition of the application, right? Which in a much simpler way. And the Shipa framework, once it receives the information from the API, it applies all the policies defined at the framework level, and Shipa starts creating all the application-related objects without your developer seeing and or having to create that. And once these applications are deployed, they can then manage, monitor, and control these applications using the Shipa dashboard. So they get a post-deployment management of their application, which solves quite a bit of the problems before around policies and governance, developer experience. And last but not least, Shipa brings that GitOps approach to Harness. So if your developer deletes the application directly on Shipa or the Kubernetes cluster, Shipa will automatically restore that application back to the desired state. So combine now, Shipa and Harness, you have the CD capabilities from Harness, and now you get your developer portal or developer platform for post-deployment management of your applications. You get policies and governance already embedded as part of the CD pipeline, and you get drift control as well. So between Harness and Shipa, you have a complete CD and continuous operation of your application as well, closing the loop between CI, CD, and the operations of your application. So let's see what the architecture actually looks like before we jump into the demo. What we're going to have is, as part of this demo, I have a Kubernetes cluster. In this case, I'm running on Azure. Doesn't really matter where you're actually running yours. But in this Kubernetes cluster, I have Crossplane installed. And as part of that Crossplane install, I have the Shipa provider for Crossplane. And I have added my Harness delegate to that cluster as well. And what changes is now, as mentioned before, instead of Harness having to have each individual cluster configured, my Harness account is now just pointing to this cluster. I add this cluster as a cloud provider in my Harness account, and Harness just communicating with that Kubernetes cluster and sending every and single app deployment that I need to that Kubernetes cluster. And in turn, my Crossplane and Shipa provider is actually communicating with my Shipa Cloud account API, right? And that API, once Harness sends the app information, for example, it communicates with the framework, the different frameworks that I have to deploy my application across the different clusters that I may have, right? Clusters may be, again, on GKE, AKS, Rancher, it doesn't really matter. And a big thing, again, is as you scale, all the communication between Harness and your different clusters are made through this Shipa Cloud provider and single cluster instead of having to configure manually each cluster. In front of us, following basically the architecture that we drew here before, I have an account using Shipa Cloud, and that's my dashboard. I'm logged into my account, and from a Shipa perspective, I already have frameworks that I previously created, which I'm going to be using this one for our sample here called prod EKS. This prod EKS framework that I defined before, is already bound to an EKS cluster, so an Amazon Kubernetes cluster. And I'm going to be deploying my application through Harness and using GitOps using the prod EKS framework. If I look on the application part, I already have an application that I deployed previously using Harness, and we're going to be deploying a new one, right? From a Harness setup perspective, let's see what I have. First of all, I already have a delegate installed, a Harness delegate installed in my GitOps cluster, together with Crossplane and the Shipa Crossplane provider. The second part that I already have a Kubernetes added to my Harness account as a provider, And that is the Kubernetes, the GitOps Kubernetes cluster that I have with Shipa and Crossplane installed. And here I have the master URL, and I'm using a service account token to authenticate to that cluster. And I created a new one called Shipa token, right? If you want to learn how to create a Shipa service account and token, you can come to our documentation where under learn.shipa.io/docs, you have connecting cluster section here. And in this connecting cluster section, you have how to get the address of your cluster, which is basically this address here. And you also have the instruction on how to create a service account for Shipa, running this command. And later, after you run this command, how to get the token for your service account, which is basically the Shipa token that I created here. So that's what I have from a Harness perspective so far, right? I have my delegate installed, and I have my cloud provider added, my Kubernetes cluster with my GitOps stuff already added there. Now let's go and create a new app. I'll call it Harness App 2. I'm not gonna sync with Git or anything fancy. I'm just gonna do a simple example so you get a taste of how you can enable GitOps with security and governance and a developer platform together with Harness. So I created the app. The next step for me is to add services to my app. I'll add a service and I'll say Harness App 2. I'll keep it deployment type as Kubernetes in this case. You're gonna see that Harness automatically create a Helm for me, which my developer would have to understand all that stuff from a deployment, namespace, services, values, and all. Let's get rid of this complexity. My developers, they don't need to see any of that stuff. So we delete these. We delete this as well. Great. So now it's empty, right? I'm gonna be using a simple definition of an application. So if I come in here and I say add file, I'm gonna say harness app2.yaml, for example. And here I'm gonna edit the file directly here. And what I'm doing here is I'm first creating an app on Shipa. So I'm gonna change the name and say harness app2. The owner of the app is gonna be Shipa team or whatever other team I have access to on my Shipa Cloud account. And the framework I wanna use, which is prod EKS. If we go back here, it's this framework here, right? Which someone from my platform or my DevOps team already added this framework and bound it to a cluster and gave me access to it. So I'm just gonna use this one. On the second part, I'm just saying it's an app deploy. I'm gonna be deploying the image actually to that application. So I'm gonna be deploying to my Harness app 2. And here's the image that I'm gonna be deploying. Great. I did this. So the next step for me is to add the environment where I wanna run. So if I come in here, Harness app 2, I can come to environments. I'll say add environment. I'll say harness app 2. I'll say it's a production environment just for the sake of simplicity. I'll add the infrastructure definition. I'll just say harness app 2, for example. It's a Kubernetes cluster and deployment type is a Kubernetes deployment type. And the cloud provider is Kubernetes. And I can submit it. Great, so this is added. The next step for me is to, now that I have added my services, I have added my environments, now I'm gonna add a workflow. So I come here, add a workflow. I'll just say harness app 2. The workflow type, I believe for Kubernetes, Harness doesn't support basic deployment for certain versions. So we can say rolling deployment. We'll say it's for my Harness app 2 and service Harness app 2 and Harness app 2 for my infrastructure definition. This is created. I'm gonna delete this step in here in the deployment and I'm gonna create a new one just so you see. Add a step. Harness is loading. Let's just close it and try again. Okay, great. So for this step, I'm gonna be using an apply. And the file path is gonna be harness app2.yaml, which is basically the file that we created before. I'm not gonna select anything from here. I'm just gonna leave it all as default. I'm just gonna make sure that the file name is correct. So if I come here to services, harness-app2.yaml file, great. So quick review, we created our services, right? We created our environment where this should run. We created the workflow with one just single step that is gonna run and apply from the services that we created before. And now I'm just gonna create a simple pipeline. I'm just gonna say harness app2 and submit. I'll just click here to add a pipeline stage. And the workflow, I'm just gonna say an execution step. You can go crazy and add approval steps and so on, but just for the sake of simplicity, I'll add harness app2 and I'll say submit. That's it. We can come in here and say, for example, and have a look at what we have here already. We have some new stuff coming up for the deployment, so on, that we have done before. Great. And I see here something that I've done before with harness app1. Just a quick test, and we're going to be doing the same with harness app2. If I come into the pipeline that we just built, I'm not going to add triggers or anything. If we just come here and say deploy and submit, harness is going to start the deployment. So here, harness is going to connect to the cluster where Shipa and Crossplane are installed, and it's going to pass the instructions, and deployments are going to happen, right? If we come to Shipa, to events, we can see that there is an app create for harness app2, and there is an app deploy for harness 2 as well. If we come here, I have harness app2. If I log in, I can see all the details on who owns the services. I can start seeing transactions for my application as soon as activity starts rolling into the application, such as access and so on. I see the resources, the units that were deployed, where it was deployed in case it's a multi-region cluster, the life cycle of my application, everything that happened, the security scan. So everything that Shipa enforced from a framework perspective, you can see here. You can also do the integrations into your incident management tools that you may have, so Slack and PagerDuty and others, so you can receive alerts regarding this application. You can see the network policies that were enforced by default by the framework, or you as the application owner, you can create new network policies, and so on and so forth. You can see application dependencies that are running, network dependencies for your application. So now between harness and Shipa, now you can deliver a full GitOps experience on a much easier way for your developers to consume and deploy applications, no matter where they're deployed in terms of how many clusters, and you ensure that security is being applied together with harness. And because this is a GitOps approach, if I come in here manually and I delete this application, for example, so in this case, there is a drift from my desired state, right? My desired state is to have my harness app2 with the definition that I did before. So if I come in here, I'm gonna see that in a few seconds, Shipa is gonna start recreating the objects and redeploying the application. So it brings back to your desired state. You can see that app create is already running. It finished actually running for harness app2 again. And you can see that the app deployment is here. And if I come in here, app2 is already here again. And if I access the app, I can see my application running. So together, Shipa and Harness can offer a full CI/CD pipeline with GitOps enabled across many clusters, with a developer portal and platform attached to it, governance and policies attached to it, and GitOps. You can go really beyond that, right? You can actually use Harness to create the frameworks in Shipa, and you can also have the Shipa application operating model to have Harness deliver the applications across not only different Kubernetes clusters, but also Linux servers, say using VMware or EC2 machines and so on. So you can have Harness deploying the same application definitions using Shipa across different infrastructures. You can have drift detection across them. You get the policies and governance automatically enforced and so on. So both applications together, Shipa and Harness, becomes a really strong CI, CD, and application operating model together. I hope that was helpful to give you an idea of how both tools can solve a huge problem. Thank you.